Also, just to reinforce with a few more examples, the concept of application layer services, what their predicted and predefined layer 4 protocols are, and the well-known ports for the services. Let's do an example for NTP, Network Time Protocol, which is used for a client, for example, to request the time from an NTP server and then synchronize its time, and SMB, which in a Windows environment is used to move files back and forth. So for example, this client here in a Windows environment may want to send files or get files from this server here. So it could use SMB for that, server message block, and also SSH. And SSH is a great secure tool if a machine, for example, right here, wants to connect out to a server or a router or a switch and get a command line interface access, like a command prompt, to that device and have the entire session secured. We can use SSH for that, where in those cases, the servers, the routers, and the firewalls would be running an SSH service, and the client would be running a client that could connect and take advantage of that SSH service. So this would be the application layer service in this column here. And next, let's take a look at the layer 4 protocols that are used by those application layer services. And once again, I'll color code the protocol based on the layer 4 information here. So at layer 4, NTP uses UDP, User Datagram Protocol. SMB uses TCP, and SSH uses TCP. And then for the well-known server port for those services, I'll go ahead and put WKP for well-known port. And for NTP, the well-known port is 123. And when the client makes an NTP request, instead of using a random high-numbered source port local on the machine, it'll also use the source port of 123 for that request. So that well-known port 123 is used by the client and the server when that client is making an NTP request to a time server. For SMB, server message block, which is used for file sharing, it uses TCP, and the well-known port for the server for SMB is 445. In the case of a client making a request to an SMB service for files, it would choose a random, currently unused high-numbered source port for the session, and for the destination port, it would send it to port 445, where an SMB server should be listening and paying attention to. And then for SSH, the well-known port for the server for SSH is TCP port 22. And very much like SMB, when the client makes a request, it'll just grab a currently unused high-numbered port for that existing session over to the SSH server. And to help reinforce that, let's take a quick peek at 3 packet captures, one for NTP, one for SMB, and one for SSH. And the key takeaway I want you to have is the well-known port that's being used by those application layer services, including whether it's UDP or TCP at layer 4. And here we go. So first of all, NTP inside the client NUG computer, I've got this folder called packet captures, and here's a packet capture called NTP. Right in the title, it says NTP UDP port 123. We'll double click on that to open it up and just confirm. So if we go to the first packet here, it's showing that it's NTP, that's the application layer service. The layer 4 protocol is UDP, and the destination server port is UDP port 123. Now in the case of NTP, the actual source port, it's also going to use 123. However, for most application layer services, when a client is reaching out to a server, most of the time with most of the other application layer services, it's going to just choose a currently unused high random port. NTP is an exception to that, and as we looked at in the previous video, DHCP services are also an exception to that. So we'll go ahead and close that, and next let's take a look at the SMB capture right here. So if we open that up, and let's take a look at the very first part of the TCP connection here. It's coming from source port 57,181, going to the well-known port 445. And that's used for the three-way handshake. And then once that's done, they start communicating and talking with SMB. Again, the destination port is TCP port 445. And then the third one was SSH. So let's go ahead and close that capture and open up the SSH capture right here. And we look at that. Here we have the initial three-way handshake. That's confirming the client can connect to the server and vice versa. And if we look at the packets going to the server, we can see the destination port is TCP port 22. Going on this first SSH packet there. Once again, the source port is some high, currently unused port that the client wasn't using previously. In this example, 57,173, going to the destination port of TCP port 22, which is the well-known port for SSH. So now that we've taken a look at many of the concepts regarding protocols and services and port numbers, including which layer 4 protocols are being used, for example, TCP or UDP, in the next video, I'm going to put you, my friend, on a hands-on lab so you can get up close and personal practice in remembering and recalling several of the well-known application layer services, also including what layer 4 protocols they use and the well-known ports associated with those services. So when you're ready, I'll see you in the next video for the hands-on lab.